Hello. How's the sound? We're going to slowly get into the mood of computational design and parametrics in this nice model. In this nice morning. Five more minutes. Just reading the patch notes right now of BeeGraphy. The quick ones. All right. So, hello. Welcome everyone. I guess we begin slowly, right? We begin slowly by just generally talking about parametrics and computational design and its place in the universe and, do we need it? And if we do, where do we use it? What's the scale? 'Cause I was thinking about this. I was thinking about this for a while. Because I do teach parametric design in the university, both bachelor students as well as master students. And I was wondering, is it necessary to teach it, or is it too much of a specialty, too much specialized, right? And I will not tell you the answer just now. I think we still need to kind of talk a little bit. I do have my thoughts about it. I'll share them a bit later, but I'm curious to hear from you guys from the chat. What do you think? Where is it useful? How many people can get a use out of it, and so on? Many familiar names in the chat. Hello. Love your videos. Have recommended you to... Okay, I don't know how many Rhino beginners. Happy to hear that. Thank you. Khalid with I don't think it's too niche. The use case or for it or the software itself? Because I can talk from the perspective of an architect, right? I can just generally, because I also work for very good architecture company. Generally, we don't use parametric modeling that much, simply because the scale of the material that we produce is a bit lower, right? So we usually do family houses, and family houses, they're quite budget limited, but all of the money goes into the manufacturing cost, right? The materials and so on, and the labor, So in that regard, optimization or form finding or anything that comes with parametric design is off the table, unless we want to do like catalog housing, then it makes sense. But catalog housing attracts a certain type of a client that we don't want to attract. We want it to be quite individual. And then you have all of the site restrictions, regulations, and so on that makes the system so chaotic that you simply cannot create a rule set for it, right? But this is us talking about a house as one entity. If we talk about separate like parts of a house, yeah, from time to time we do use parametrics, right? For very boring stuff, but still we do. As a minimum parametric design, oh, hi Learning, one of the founders of BeeGraphy. As a minimum, parametric design is a good thing to teach logic. The approach itself is beneficial for everyone. I agree, yeah, that is true. You don't teach the form, you teach how to create the form. You know, what's the logic behind the form or the space, you know, in the world of architecture. By the way, is the music not too loud? If it's too loud, just let me know. I'll tone it down a bit. So I'm reading the chat. So you don't think that it's niche? I'm not sure. I'm kind of on the edge of it, because I also see that there has been a wave, you know, of parametric design adoption, and ever since the, I don't know, like 5 years ago or so, or something like that, the wave seems to be either stagnating or slowly going down, and hopefully it's just a cycle, you know, and it's going to go up again, or maybe it's just the hype is gone, because we had, you know, you always observe this NFTs, and then we had the metaverse, we had the metaverse before, and then we had NFTs, and then we had AI, and people really jump onto these trends, right? And then they get kind of over enthusiastic about these trends. They think that it's going to be, you know, completely a new world after the creation of whatever, metaverse, NFTs, blah, blah, blah. And then it doesn't happen. And then they get kind of discouraged. But then, from time to time, it does happen. So it's hard to say. In terms of parametrics and so on, I think it's a similar cycle, like the hype cycle. It's just that the cycle is much lower, and it has the tendency to repeat itself. Maybe I'm losing a few people here with my talk. Anyway, but at least that's my thoughts on it. It seems like we're in this kind of a period of computational and parametric design where everyone who is into it already knows what it can do, and like people who see parametric models and computational design, you know, designs, people tend to be, it's the same thing. You keep showing me the same aesthetic, the same concept, you know, of either topological optimization or rationalization of form, or you know, all of these things. And it has become just this tool that is able to do, you know, multiple things, but it stopped spreading outwards as much, right? Which I think is that's where the stagnation comes from in the human eye, or the public perception. And I think it's going to be revitalized. You know, it's going to go up again. I'm not sure when, but it will, right? So that's at least my hope for it. Okay, that's a lot of chat. If I missed something, I'm sorry. Just spam me again. I'd like to see more parametric design in architecture, particularly in schools and apartments, hospitals, etc. Well, it depends on what's the use case for it, I guess, right? So if it's just parametric design for the sake of parametric design, I think that's what people are tired of, is like fancy facades that don't really do much. They're just kind of expensive and, you know, visually complex, but you can achieve the same visual complexity without really doing computational design, you know. So I think that that's what is kind of forming the public perception again. And when I say talk about public perception, you know, it's very easy for me or any teacher in the industry or any developer in the industry, you know, of these computational design tools, to stay within the bubble of the community that is always hyped, that is always, oh yeah, this is the next big thing. But at the same time, when I position myself outside of that bubble, you know, becoming a YouTuber and looking at the trends and what people are watching and, you know, where things are going, I do see stagnation in terms of, you know, computational or parametric design. That's why I'm bringing up the topic in the first place, right? When I talk with my colleagues in the university, everyone goes like, yeah, absolutely, it's, you know, it's the future. It's never going to change. It's like everyone is just talking about it. Yeah, of course everyone's talking about it because you're in the you're in the university that teaches it, right? So you're attracting that kind of public, and you're in this bubble that's doing the same thing with developers and how do you call them? Conventions, I guess. Not conventions, like where people give talks, whatever. You know, you need to look at the broader picture, and it's very hard to do so, right? When you're surrounded with people that are doing the same thing as what you're doing. So I think I have a fresh perspective in that regard, right? On the topic. Should we kind of do the workshop? Well, not the workshop, I guess the showcase a little bit. I'll introduce you to, you know, computational design tools, and we can keep on talking about it, you know, as we move forward. I'll just read a few things. Conferences, thank you. Yeah, I'll just read a few things from the chat. The idea is to fill space. I'm very conscious of not talking and you just sitting there in silence. Oh, thank you. I really love your content. Thanks. I try my best. Oh yeah, this workshop or this course thing, live stream, is being recorded, and I will be, either it's going to be uploaded on my channel or BeeGraphy's channel. I honestly do not remember what we agreed on. I believe it's going to be uploaded to BeeGraphy channel, right? So just make sure to follow them, and you'll be able to see it, you know, past the live time. My English will get better. It's been the whole damn summer where I stayed in Lithuania and I didn't practice my English. Well, for a month I stayed in Japan, so Nihongo Jozu. But then I stayed in Lithuania, and now my English is broken, so I need to get back on track, so to say. Differentiating between public eye and what professionals think is important, catering to the public eye for commercial gain is saddening to see. Okay, yeah, I agree to that. Well, in terms of parametric design, I'm currently struggling with CAD to Substance Painter workflow. The UV and retopo is required all the time, back and forth. Oh yeah, so optimization of boring tasks. That is one way of how you can use parametric design in a very constructive way. And that's actually a way of how we use parametric design in our architecture office. You know, floor skirting, I guess it's called. You know, the connection between the wall and the floor in the interior, and you have that little plank that goes along the perimeter. It's always a hassle to model it out precisely, because we do like higher quality ones are recessed into the wall, and then you need to do some Boolean operations and so on, and then when it makes a corner, it's all weird. So a script that does that, so that immediately saves time. Then roof slope calculations, landscape slope calculations, all of those things that are kind of boring and tedious to do by hand, we just optimize it, right? So I think in terms of like parametric design as a tool or as a means of how to construct tools is great. The moment when it becomes just a visual thing is bad, right? At least that's my take on it. Or I mean, if that visual thing inspires people, I guess that's great as well. But anyway. I look younger than before. Yeah, I shaved. I literally shaved. Anyway, let's move on to BeeGraphy. So, in terms of this workshop or this showcase, I guess I first should introduce what the hell this is. You know, this platform and so on. For those of you who don't know. So I guess viewers of my channel are familiar with Grasshopper for sure. Houdini, Grasshopper, geometry nodes for Blender, or the blueprint system in Unreal Engine. All of those are graphic editors, right? Like visual programming or whatever you call it. So basically node editors to create code that executes something. And all of them are running on your machine, meaning that you need to have a pretty powerful machine. So this platform, the BeeGraphy platform, alleviates that. So it makes it all run on their servers. So it's browser based. And I do think that that's where many technologies are kind of moving towards. It's you know, distributed. It's cloud based, right? It's becoming cloud based, which is nice because then you can bring your work to home a little bit easier, and you can carry, you know, all of your stuff around. There are of course restrictions that come with that, but I guess we'll get into those a little bit later. It's basically the like would you like to render on a server, like 3D render on a server, or would you prefer to 3D render on your computer, right? There are benefits and drawbacks for both. In this case, it's the server, right? So I believe they are still in beta. They're still in beta stage. So most of the tools that you see here are still kind of a work in progress and so on, but it's basically a platform that's aimed at designers and product design mostly. It's those of you who worked with Grasshopper will see a lot of similarities, right? So it's basically CAD design or CAD parametric design in a browser. A very useful little thing. I guess let's begin, right? So you create your account, it's free. You click on editor, and then this is all of my, you can see all of my testing for live stream. You know, all of the different definitions that I have made. Are these called definitions? These are called models in BeeGraphy, same thing, right? That I've made. The creator of BeeGraphy is talking in the chat. One secret I have to share: we keep the data in the cloud, but the computations and rendering is still done on your computers. Oh, is that right? Okay. Okay, so you can't run it on or can you run it on a really crappy computer? Does it still run then? Since the data is in the cloud, you won't lose data. It's always accessible from any device. You don't need to install, just log in. How heavy is it in terms of computation, right? If I guess it gets pretty heavy, but you are working with meshes under the hood, right? Or is it NURBS based? That's kind of interesting to me, because I thought that the computation is also done on the cloud. I haven't noticed that any change in computation speed switching between my laptop that is very weak and my workstation that is quite powerful. So I assume that it's the computer is not doing much. Okay, gotcha. So very old computer or slow phone is a no-go. Well, with that being said, it's fine, because most of the designers that deal with CAD stuff have a computer that is capable of doing CAD stuff, right? So there is a certain threshold, certain baseline, of the computer's performance that all of us have. Anyway, so once you're in your workspace, you just create a new model and you name it whatever. We're doing a lamp, right? So I'll just name it lamp 01. Just create it. That opens up your viewport, or whatever it's called. Canvas, I guess. Let me just move around just to introduce you to, wait, is that view? Just to introduce you to what you have here in the canvas. There's the viewport, so that's where the 3D model is going to be located, and this is where you add all of your nice little nodes, right? The logic for it. And I think, okay, let's begin with a simple thing, right? So let's create a point. So you can either double click and just type in construct point, and that will give you the node to do so. Immediately zooms into it. Or you can just go to, that's interesting. Why are there no... Well, am I missing something? Why are there no nodes here? I mean, that's fine. Usually there are nodes that we can check here and that we can drag and drop here, but in this case I do not see them. Let's restart. Let's see if that's going to help. Okay, sure. After restarting, that just opens up. Anyway, so the construct point is also accessible through tools, and you expand that, and here you have all of the different tools that BeeGraphy has to offer, right? And as I mentioned before, the Grasshopper, like it's quite similar to Grasshopper. So if you're familiar with how it's called in Grasshopper, you'll be able to see it or to find it quite easily. And under vector, the first one is the construct point node. Okay, so in terms of the construct point, what you want is it to have 3 numbers, right? 3 values. And let's do, okay, so sorry, I'm jumping around, but what I want to do is I want to do a laser cut pattern for the lamp. So we will use this kind of parametric design to define some sort of a pattern that fits very neatly in a compact, sheet of plywood or whatever. It will get cut out and then reassembled into a 3-dimensional thing. thus making it so that we save money, right? Because and we save material, right? So it becomes quite eco-friendly, right? So what I want to do is I want my lamp, all of the cuts of my lamp to fit within a certain boundary, right? And for that I want to do two curves, one outer curve, one inner curve, and then basically create a bunch of curves in between them, right? The cut lines. And once we move forward, you'll understand what I mean a little bit better, right? So for now, let's just create this construct point. Let's create another one, construct point. You can Control-C, Control-V as well, you know, copy paste. That works as well. But for the second construct point, I will give it a little bit more, whatchamacallit, a little bit more space in the Y direction, as well as the X direction. So for that, I want to create a slider, and I don't think it's called a slider here, slider. Okay. If I type in slider, it does give me the correct correct name of it, which is range input, right? And then I just expand it and I define what's the minimum and what's the maximum. So for the minimum, I'll say minus 400 millimeters, and for maximum, I will say 400 millimeters. And step size can be just 1, that's fine. So the reason why I'm saying minus 400 and 400 for this range input is because that's the typical size of cut size of a laser that you get from AliExpress or something like that, right? Do the nodes have identical names to Grasshopper? They do not, but it's really close. And I mean, construct point, tween curves, and so on, most of them do, some of them don't, right? But if in this case, you know, I typed in slider and range input was, you know, exactly the same. So I'm just connecting range input to Y, Control-C, Control-V, connect that to, to X, connect the copy of it to Y, like that. And then for this one, I'll just say 100 units, like that. And then for this one, I'll say minus 200 or something like that. There we go. So now we have 2 points, you know, one at 0, 0, 0, and the other one at 100, minus 200, 0, right? Let's keep copying. Now I'm going to just select these 3 nodes, Control-C, Control-V, copy paste, drag them down. And I know that I will need one more, so I'll just do it right now. There we go. 4 construct points, and how many are there? 1, 2, 3, 4, 6. Counting is hard, okay. Hello from Algeria, hello. So with these 4 points, I want them to be basically going along in a circle, clockwise. Is it clockwise? Yeah, clockwise in a circle. So to do so, basically the point number 3 needs to be somewhere here where my mouse is, right? So that should be in the X direction. It should be around 0. And in the Y direction, it should be at like minus 400 or so. Something like that. And then I will have the final one. It's going to be like, I guess minus 200, something like that. Let's just do the first one, 200, so that it's kind of clean, right? So 200 minus 200, 0 minus 400, and then minus 200 minus 200, 4 points. Let's make a curve out of them. To do so, we just use interpolate. I wanted to say interpolate curve, but hey, interpolate works. So we just use that node. There's also a possibility to use NURBS curve, but in this case, I want to force the curve to go through the points, which is the interpolate option. I can actually show you both, it doesn't matter. I'll just do interpolate, right? The thing is that interpolate right now can only receive 1 point, and technically you could do it this way, that you connect your first construct point to it, then you hold down the shift key, and holding down the shift key you connect the second one, and so on. But let's keep it clean, right? So instead I'm just going to click on point 1 and just add port, select add port. That gives me point 2, and I'll do this 2 more times. Add port, 1, 2, 3, 4. 1, 2, 3, and 4. There we go. Draws a curve, right? Now to actually close the curve, I just tick mark here, the Boolean option. And now we have ourselves a little hard looking, apple looking thing. Maybe it's because it's red. And then for the degree, degree 2 is, I believe, arcs, right? So it's made out of multiple arcs. We change it to degree 3, which is a true Bezier NURBS curve. Anyway, so with that done, we have our first shape that should fit roughly, because it goes, since it's interpolating, it kind of is going beyond the 400 millimeter mark, but it's roughly fitting within the 400 by 400 millimeter mark. And basically what we want to do is we want to repeat the same process, but in this case we want to create a smaller curve inside, right? So that then we can make a lot of sections in between, right? Can you maybe move the viewport to the upper right corner? Otherwise your face obstructs the viewport a bit. Oh my god. Thank you. Thank you for telling me. And sorry for that. Wait, it should be fine, right? Let me just check if it's fine. Oh, we can even make it a bit bigger. There we go. Okay, something like that should be okay. So back here. Oh, Paras. Hi. Hi. A long time viewer came in. Everyone say hi. Okay, so to make a second curve inside, I just select the whole damn thing that we have created. Control C, Control V. Make a copy of it. Drag it down, and then I just mess around with the range inputs, right? So I'm just going to change this to like the first one we don't, or actually we should change the first one as well, because we want an offset for the first one. So I'm just going to get one of the range inputs for the Y direction, like so, and just drag it a little bit down, something like that. Then the second number in X, that's a little bit smaller, like that. You know, closer to 0, something like that. And then the final ones, like that. And that is. We will do those kind of things a little bit later, where it's self-intersecting, but not right now. Self-intersecting is fun, but we don't want to do it just yet. Okay, so we have two curves, and you have full flexibility of how you can control their shapes. That's great. That's what we want. So now it's time to create a bunch of sections in between them, right? So after we finished with the interpolation, we will go for a tween. It's called tween, between two curves. Just 1 second. My whole streaming setup is messing up. There we go. So to create a bunch of sections in between, we just do tween, TWEEN, tween curve. And I just connect curve A into curve A input like so, curve B into curve B input like so. And then for the factor, we need to use some number. So in this case, for now, I will just create, like, double click and just type in 0.5 range input. And I'll just connect the number to it. And you can see there's a curve that is tweened between the two. And if I move this number forward, it goes towards the smaller one, backwards, and goes towards the big one, right? So you're able to interpolate a curve in between the two freely, right? So one curve is cool, but you know what's cooler? 50 curves. So instead of using range input, we will use list sequence. Is it list sequence? I think it's list sequence SEC. I think you can just type in SEC, yes. And that is going to give you the option. Bam. Which basically is a counter, right? It counts the number of sorry. It just keeps increasing the number by any step size that you give it. Don't know what happened there. Within the given range, right? So if I start with 0 and I end at 1, because that's the range that we used, right? And then I say count is 5 and just connect that as a factor, how many curves does it give us? Let's just check. It gives us 5 curves. By the way, you can check things if you just click on the output. Here under value, it's going to tell you how many things there are, and if you expand that, you can't expand that, never mind, or you can, it's lagging a bit, maybe that's because I'm recording. There we go. If you expand that, then you can see all of the things that it holds. You can also create a panel, that's easy as well. Panel, connect that. Okay, not the fastest, but it does work. So now let's delete that. For the count, I want to have either a constant number or a slider. In this case, I will probably just use a constant number. And I'll just type in, for now, let's do something a little bit simpler, like 20. 20 and then number constant, like so. And connect that as your count. Creates the 20 or whatever slices. Okay. With that done, we can move forward, right? So right now the main issue is how do we create surfaces in between these? Because imagine this, right? You have your laser bed and you put down the sheet of material, whatever, plastic or wood or whatever, and then you use a laser to cut, these lines out. So what you end up having are these ridges, right? These kind of surfaces. And then you can rearrange those surfaces into a three-dimensional shape. That is what we are going to be doing. And I guess before we start arranging them into a three-dimensional shape, one thing that we could do while we're at this level of constructing points and so on is create some sort of a spine along which all of these elements should be arranged. So let's do that. Let's create the the spine. Apologies, give me a second, just a bit of coffee. Okay. So, to create a spine, we will use exactly the same procedure. So I'm just going to copy the 4 points, 6 sliders or whatever, and I will get the interpolate curve here as well. Control C, Control V, copy paste, drag it up right here. And we just do, let's do a curve above this, or we don't really need it to be above. It can be, it can start here and just kind of whittling through. So should it? Maybe it shouldn't. Give me a second. Sorry, you're my viewer. You must be used to this, me just contemplating it. No, I want it to be above. If it's above, it's nicer because then we can see both of the things at the same time and we can make adjustments to both of them. So what I'm going to do is I'm going to say the Z for the first point should be at 500. So by the way, you can just double click. Was it double click or click? Doesn't matter. I'll just type in 500. That's fine. Number constant. Like that. So the Z, the first point of the Z is at 500. And for interpolate, I will have Boolean turned off in this case because I'll just want it to be, you know, a very clean spine that is not a loop, but just a spine. So for 500, that's where we start, and we just kind of keep going, making some sort of wavy tail. So in this case, we will not be moving at all in the X direction, we will only be moving in Y direction. So let me just disconnect from X, holding the Control key, and from Y, let me disconnect all of the wires actually, just so that we're kind of on the same page, like that. And then let me just start reconnecting the wires into Y and Z, Y and Z, Y, come on, Y and Z, right. And now with this done, let's start thinking about, you know, the curvature that we want to achieve. Maybe 500 is a bit too much. Let's go for 400. So for now, for the Z, I'll just max it out, all of it, to 400, like that. And then for the Y, I will say, okay, the first one is, let's say, at 100. So this one is at 0, this was at 100, then the second one is going to be at 200, and third one is going to be at 300, and that should, yeah, that just makes a stick. Not very interesting, is it? But then if I start messing around with the curvature of it, right? So let's say the first two ones are 400, but the second other two ones are at 300, right? We get some wavy thing, which looks really ugly since it's set to be interpolated. Let's change it up to NURBS curve. NURBS curve. And again, click on point 1, add port, point 2, add port, point 3, add port. There we go. Connect the points to the ports. You'll visually then see the difference between, yeah, there we go, between the NURBS curve right here and the interpolate. Okay. So I'll just delete the interpolate curve, and we were using a much smoother, much calmer version of it. Still not sure why degree 2 is the default one. Doesn't matter. I'll just switch it to degree 3. So that's our spine. What we want is we want our slices that we have here to follow the spine, you know, and that is going to be the shape of our lamp, right? This kind of a bulbous thing. And then on the spine, on the bottom of the spine, once you have it laser cut, you just glue on the freaking, the freaking LED, the LED strip, and, you know, call it a day. So in that regard, I think we're done with the initial boring setup of the points, and now it's time to actually, you know, make it good, I guess. So first things first, let's make the spine a bit thicker, right? So I'm going to use, let's zoom into it. I'm going to use extrude curve component. Extrude curve, connect curve to curve, of course. And then for the vector, we want to extrude it upwards for now. So that's going to be z, vector z. And we just connect that to as our vector. I just want to, by the way, point it out that I have been working with BeeGraphy for a while now, since alpha stage, and how stable this has become is really nice, because I was ready to keep refreshing the page, you know, constantly. By the way, if you do get some sort of a misbehavior or something weird is going on, just F5, you know, just refresh the page and it's 99% that is gonna go away, right? So back in here, we have our, that's weird. Maybe I will need to refresh the page. We have our extrude curve component here that gives us a surface, and then we will simply just give it a factor, and for the factor I'm just going to use a constant number, like 7 millimeters or something like that. And that is not extruding at all, but that is indeed giving us a surface, right? Yeah, the surface is indeed there, it's just not showing up. F5. Hey, still not showing up. Okay, that's a little bit of a doozy, a little bit of a woozy. What if we, one second, that's how we troubleshoot. What if we move this? Maybe I'm just being stupid. No, it should work. What if we move this up by 7 millimeters like that instead of extruding it? And then we loft surface between the initial curve, add port, and curve 2. Well. Okay, it's a bug we have in the viewport. You need to go to the settings, change the quality of the viewport. Okay, yeah, and also it's that. Settings in the bottom left, quality, low, close, 5. Oh, wait, yes, it is. Thank you. Okay, so loft works, and then I assume the initial extrude surface will also work. Oops, that's extrude surface, my bad. Extrude curve. That is also gonna work. I mean, it's beta for a reason, right? Back in here. Yeah, that seems fine. Okay, so we have our 7 millimeter spine. That the height of it is 7 millimeters. Now we want to give it some thickness. So I'm going to use extrude surface for it, because now it has become a surface, right? And I just connect the surface component, blah blah blah. You know the drill. And then for the vector, we want to extrude it in the x direction. Vector x, like that. And for the as a factor, we want to use like what one? Sorry, I'm thinking like 5 millimeters. Let's do. Do we do 5 millimeters? Yeah, let's do let's do 5 millimeters. Let's do 6. Let's do 5. 5. 5 is fine. Okay, so we have our 5 millimeter solid now, right here. Let's zoom. There we go. Some thickness. But the problem is that it's now not centered, right? Hi, Philip. It's not centered, right? We want it to be properly centered. So if we extrude something to the left by 5 millimeters, we need to move it back to the right by 2.5 millimeters, half of that. So if I just simply move, where's the move? Move this solid geometry along this vector x, but 1 second, thinking. We can just do multiply. We can multiply this vector. Oh yeah, you can't multiply a vector, huh? Okay, no shortcuts. Vector x. And the factor needs to be basically this number multiplied by -2. But no, divided by -2, right? So I can just do constant number of 5 millimeters or range input, it doesn't matter. 5 millimeters, and then, it just connects to vector x, that's our extrusion. And then I can just multiply that number by, I can write here, nice, -2. You just click on the null and you write there. Thank you, Asim. Thank you. I try my best. There's gonna be more videos in the near future. There's going to be a podcast. I will market it, of course, but I did my first podcast. I'm very happy about it. I did very poorly in the podcast, but I'm happy that I've done a podcast. Anyway, it's not going to be on my channel though. So with that done, now we have moved it back. Oh, that's multiplication. I'm stupid. Divide. Division. We divide 5 by -2 to get the correct number. And now this is in correct place. So now we have a problem of too much stuff being in the same place, right? So what I'm going to do is I'm going to just click on this, right click on this extrude surface, and I'm just gonna click on hide, right? To hide it. And now we have ourselves a spine. Congrats on your, yeah, thanks. I was super nervous though. Anyway. So now this is where it starts becoming a little bit interesting, I think, right? Because what we want to do now is we want to create a bunch of boxes along. Basically, I want these to fit together neatly. Nicely. So what I want to do is I want this curve, this initial NURBS curve, to be evaluated at a specific step. And for that, for now, I will just hide the, our three-dimensional spine, and we will use just the curve. So I want to create a bunch of points along the curve, right? And to do so, there's also extrude curve that's in the way. To do so, I will just use evaluate curve component, like that. That's the curve that we're evaluating. And you can see parameter 0.5 just gives us the center point right here, right? Easy. So to actually create a bunch of points, or exact amount of points as how many lines we have here, or how many sections we have here, I will need to well, first of all, count the amount of sections, but we already have that. Where do we have that? We have that here, this number, 20 sections. So do we use it though? That's the question. Because I kind of want to, sorry, give me a second, I'm just I'm just thinking. Yeah, I kind of want to use this number constant so that it's all changed in one place, right? So for this evaluate curve, I will also use list sequence, which is SEC, which generates, you know, a bunch of numbers in between 0 and 1, not 10. And I just connect that to as my parameter. Now with the count 5, it actually generates 5 points here on the curve. And I want to actually connect this number, the 20 slices that we have, you know, here, this number, I want to connect that to the count, like so, long wire, bam. And in doing so, I'm basically just creating placement or spaces for where these slices will land on this curve. Excellent. That's what we want, right? So with that done, now we can, after the curve has been evaluated, we can actually create. First of all, let's make incisions, I guess, in the spine. Yeah, let's make incisions in the spine for the ribs to attach to, right? So I'm going to, actually we don't show it just yet. We will do that later. For now, let's create a bunch of boxes. So box, by 2 points or by center? By center. Let's go for box by center. Point connects to the origin, and we just get a bunch of boxes in here, right? Those are going to be used to create like a Boolean difference type of a operation. Then in terms of the width, length, and height, those are all kind of controlled by the thickness of the material and how deep do you want it to go in. It goes until the freaking, sorry, give me a second. It goes until the midpoint, but that's actually the midpoint is the bottom end of the spine because we extrude it upwards, right? So this is fine. So all we need to do is just define the width, the length, and the height. Just give me a second. I'm gonna see the chat. Chat is dead. Okay, that's fine. So the width, I guess we can just do something simple, like 100 millimeters, because we want to make sure that it's definitely cutting through. The length, this is, wait, let's see, what's the length, 100? Oh yeah, this is the thickness of the material that we're gonna be using. So for now, I'm going to have it a constant, like 4 millimeters or less. Let's go for 3 millimeters, something like that. And later we will fix it, right, into a dynamic object. And then for the height, that's how deep it goes in, right? And the height should be divided by 2. So 10 equals 5. If this is set to 10, then it will go in by 5 millimeters, which is fine. For now, I'm going to keep it constant. It's okay. Later we'll make these a little bit more dynamic. All right, so now let's actually look at the spine and the boxes, and you can see, you know, the arrangement of that. Actually 5 is a little, or 10 is a little bit too much. Let's go for like 8. Yeah, that's a bit better. Okay, so now with surface difference, we should be able to remove from the spine geometry, bam, we should be able to remove all of these boxes, bam. Yep, there we go, easy. Didn't doubt it for a second. And now we can hide everything here. So I'm just selecting all of this, right-clicking anywhere on the screen within the bounding box, not on the node but on the screen, and choosing to hide. And now we have our clean little plank that is ready to ingest some ribs, right? So in terms of, oh yeah, one more thing. Give me a second. I select this, I click on this little magnifying glass, so that I zoom in, and then I am able to zoom to the end. The end is going to be a little bit ugly if we leave it like that. So what I want to do is I don't want to interpolate between 0 and 1, rather I want to interpolate between like 0.01 and 0.99. So 1% of the way there and 99% of the way there. What this changes is the placement of the points, right? So 0.01. It's calculating. Okay. And 0.99. Oh, that's too many zeros. Okay, so we get, you know, this little lip here, which is nice. All right, so that's done with the spine. Now on to the ribs. I want to chill out a bit. Let's talk. Let's talk a bit. If you have an image of the final shape you are going to make and you share it, no. I do not. Everyone's focused, right? So while we're on this subject, and I'll touch upon it a bit more. Let's relax for like a few minutes. Just chat, just talk. I was thinking about, you know, the whole parametrics and browser-based parametrics, and where does BeeGraphy come in, and where does it fit? And I think the main issue with the platform is just the sheer amount of professionals or amateurs that are interested in this type of a thing and that would use this type of a thing for their work. So what do I mean by that? If we look at the whole field of design, everything that's design related, game design, whatever, right? You have this whole balloon. Then inside of that balloon lives product design, or plus architecture, plus engineering, plus everything else, you know, a pretty big balloon inside of a much bigger balloon, right? Then inside of that, you eliminate all of the things that are real-time, visual-based, effect-based, and so on, right? So you basically, initially you leave with production-oriented things, right? CAD design, mostly, right? Well, also, I guess Blender's geometry nodes also falls in there. So, but let's just say CAD design, right? Even smaller balloon there, right? And then within that field of CAD design, you have static CAD and dynamic CAD, right? So static CAD being, you know, as I mentioned before, architects that just draw in AutoCAD and they produce drawings, they send them in to the municipality, municipality approves them, GG, go next, right? That is, I would argue, in the world of CAD, that is above 99%, right, of all of the usage. So you're left with 1% that is interested in automating tasks, right? in also learning how to automate tasks. And within that 1%, you're looking at basically BeeGraphy is competing with Grasshopper, as well as I guess geometry nodes also falls into it, not so much, but it kind of does, as well as all of the professional tools that Siemens NX has, Katia has. All of them have these parametric, like integrated parametric tools in their packages, right? So suddenly, like in terms of professional use for product designers and so on, that is becoming a problem. Not a problem, but for the professional product designers, they already are using their Siemens NX or Katia or Fusion 360 or whatever, or Grasshopper, right? So they will not transfer, right? There's no reason for them to transfer. There's no value in them transferring. So basically any kind of a newcomer, and here I'm talking about BeeGraphy, but I'm generalizing, right? I would like to generalize that it's not just BeeGraphy, it's any kind of newcomer that is coming into this scene will have the problem of it being somewhat oversaturated with parametric tools that are available and the community that is built around those tools. In terms of Grasshopper, there's so many plugins, for example, right? So it's very hard to fight that with a value proposition, right? So one way of how BeeGraphy fights that, which I really enjoy, is the monetization strategy, right? That it's free. So you can just jump into it, and you don't need to buy Rhino, you don't need to buy Katia, you don't need to buy anything to actually use it. And the only way of how they monetize it is through the taking a cut if you sell your stuff on their own marketplace. So you use their tools, you create some sort of parametric object, another person comes in, purchases a version of your parametric lamp that you have made, and then they get a cut from it, and that's the monetization strategy. I think it's going to bleed for a while. It's going to bleed money for a while, but I am a fan. I mean, I think it's really, really nice. A really, really nice monetization strategy. So, but back to the topic. The issue that I see is that professionals have the tools that they use, and it's very, very hard to steer them away from those tools. You need to have some insane level of value add for them to change it, especially in a production-based environment, right? We, as an example, in our company, we are still using V-Ray, even though V-Ray has not innovated in 3 years or so, and now Twinmotion, D5, all of these render engines are just better, right? Unreal Engine is better, right? So, and the only reason why is because there's so much work to do for the people that work in the office that they don't have the time to learn the new tools, and the value proposition of with V-Ray they do a project or they render out a project in 4 days or so, and then with Twinmotion they will do the same thing in 3.5 days or 3 days, right? That value is not enough for them to migrate and to actually put in the resources to learn it, right? So even with something, and Twinmotion is free, so we are initially basically paying for a lesser product. Well, not lesser, but we're paying for a product while we have an alternative that is free and objectively, in my at least opinion, better, right? So then the question is, who values free stuff? And Michael has it has it down. Students value free stuff, and amateurs, people who tinker, people who do not produce in a large scale environment, that don't need to produce day after day, but people who tinker and who have time on their hands, right? So I would say old folks and students mostly. And that's fine. That's fine, because being able to offer a free parametric tool for students, such as BeeGraphy, like a platform for training them so that they have enough knowledge of parametric design, and then once they graduate, and let's say they can't afford Rhino or whatever, but when they graduate, they will have, BeeGraphy listed as their set of expertise. A person who is going to be looking at the portfolio and going to be looking at the parametric stuff that the student has made will be able to extrapolate that, okay, this person, for us to train this person to use the Siemens NX system, or to use CATIA system or Grasshopper system, is going to take like 10 times shorter amount of time than a person who has not touched parametric design in the first place, right? So I see BeeGraphy as a great training platform for that's for free, and just kind of raising awareness. And as Michael said, the 1% of people who use CAD for automated CAD or parametric CAD or whatever, simulated CAD, that 1% is growing. It used to be the case in this, and then I noticed the stagnation, right, in its growth. And my hopes are that a platform such as BeeGraphy that is free is going to revitalize that growth a little bit, and then will give us a little bit more fresh meat, right? So that's at least my thoughts on it. Many people that might find too much complexity in tools like Grasshopper would now have an alternative. Well, the problem is, I understand what you're saying, but the problem is that the complexity of Grasshopper is there for a reason. There are certain things there's a lot of things that you are able to do in Grasshopper that you're not able to do in a more simplistic version of Grasshopper, such as BeeGraphy, right? So it's for example, is it possible for me to, 1 second? I know you don't see the screen, just give me a second. Pop. If I go to the market here, this is by the way, the monetization strategy that I was talking about. You purchase something, right? Like a CAD file or a manufacturing file or a 3D print file, of a thing, and then BeeGraphy gets a cut from it. In this case, most of these models are free, which is nice to see. Anyway, L system. Let's go for this. I guess that this will work, right? So someone did a very nice L system, Limbenheimer. I never remember it. Basically, a stick grows into 4 sticks. Those 4 sticks grow into 3 more sticks. Those 3 sticks grow into blah blah blah, right? Tree. All different ways of how you can create trees, and then you can change the curvature of the branches, and it updates, and then you can download it as, I assume, OBX file or something like that, and add it wherever you want, right? So very nice parametric model, showing iterative growth. The problem is, notice how, thank God, I was just looking at, notice how there is no slider on how you can control the amount of branches, right? Of how many times it multiplies, right, of how many times it grows. And that's because the poor Arman had to, for every generation of growth, had to just take the script and just copy it, right? so that it kind of repeats itself. And that is because there is no loop, right? It's not there's no functionality for looping things in BeeGraphy. And you might say that, oh, there's no functionality of looping things in Grasshopper. Well, there are. First of all, you can code. You can just do Python or C# script that is, in native Grasshopper, or much more easier, you just download a simple plugin and then you get the functionality of a loop, right? And there are so many things that you cannot do without having a loop, such as, a controlled L system growth. In this case, right? You can go up to 5 branches, and then if you want to do branch number 6, well, you need to go back into the script, copy it again, and then you will have branch number 6. That's my point, at least, for it. So while simplistic things are nice for tinkering and for simplistic stuff, once you get into the real world applications, not just, a keychain or a trinket or something like that, right? Once you get into real world applications, real world is complex, and real world requires really complex systems to solve it or to operate within it. And for that, the tools need to be complex. The UI can be easy, but the tool itself is complex. Impressive tool for online task automation. Huge thanks for the workshop. My pleasure, Henry. Can we come up with a friendlier name than parametrics? I think the word alone turns off the creative part of the brain. Parameters, right? Well, it depends on what you call creative, what is creative to you. For me, creativity is not necessarily artistry, right? It's not necessarily artistic. Creative can be like advertisement strategy can be a creative thing, right? A way of how you shuffle around numbers can be creative. So I don't think that it does. The name itself goes against the creativity aspect of it. I don't think so. I do think that the examples that we see that come from the field of parametrics or computational design, the visuals that we see, show a lack of creativity. And I mean, I'm gonna get cancelled for this. Okay. I have noticed, damn, this is gonna be spicy. I have noticed during my teaching that people that go for, not all, this is just statistically, lowering the blow, statistically, people that go for computational design and people who go for parametrics and blah, 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 tend to optimize their the creative process. They want to optimize it, and in doing so they completely disregard any creativity, and they just get fascinated by the optimization aspect of it, right? And in turn, maybe they are creative, but I haven't seen them act in a creative way, right? So at least from the student perspective, I always notice that students that usually push back on the optimization or automation of things usually have a much stronger, on average, a much stronger sense for aesthetics, much stronger sense of the dynamics or composition and so on, right? And creativity in terms of looking at the thing from a different way. Students that immediately go really deep into programming, into computational design and so on, tend to really hyper focus on the programming aspect of it, and they disregard the aesthetics, they disregard a lot of it, and then they just get the aesthetics for them come from the beauty of the code and the beauty of the complexity that the code generates rather than the beauty in itself. So that's actually one of the reasons why I really try to do a lot of things on the YouTube channel, is that I think it needs to go hand in hand. Let's optimize the world, let's parametricize the world aspect of it, and the let's just sit down and paint in watercolors, and talk about our feelings aspect of it. I think those need to come in hand. But if you just say math is beautiful, right? And it's just math, and you keep showing me that kind of spirally thing, the golden ratio spiral thing, and look how beautiful this is, math. I'm like, yeah, I've seen it. Yeah. Not creative though. It's nice proportion, but can we go back to watercolors, please? I like how the color drips. Anyway, that's a little bit of a rant. So always try to catch yourselves, right? If you're really into the computational field, think of what is it that you're giving away and how do you bring it back, right? That's very important. L system tree looks like a fractal model. Is there any best way to make a loop function? Would you show me an example? Oh no, so that was my point. That's the point. You can't make loops in BeeGraphy yet. In the future you will. I'm sure of it. I mean, it's definitely not like in any kind of a computation programming language. It's not a problem. It's just the function is still not there, right? So that's just one of the tools that's not available yet. And with more and more tools, the complexity of the interface itself is going to be a little bit difficult, more difficult to navigate, which is fine. For me, it appeals more to engineers than creatives, and there is the middle ground that is where the future lies. Yeah, the creatives taking back the engineering and engineers digging into the creative a little bit. I wish that engineers dug into the creative aspect of it a bit more, though. That's my point. Computational design at the moment is what UI design was in 2003. I don't remember what UI design was in 2000. I remember how shit it was, but I don't remember. I don't remember the things that happened in 2003 with UI design. Did it have some sort of a resurgence afterwards? Of course it had some sort of resurgence, but perhaps there was stagnation. But I do argue that there is a certain level of stagnation. Now everyone is looking at AI as the next thing for automation and computation and so on. And I don't think it's that. I don't think that, I mean, it's definitely a thing. AI is definitely a thing, but I'm not sure. I need to think about it more. If you have ideas of computation design and AI and how it, one influences the other, write in the chat. I'll read it after this next batch of the workshop. Let's finish up. Let's do the second part of the workshop. We have rested a bit, and then we'll talk some more, right? So back here, we have our surface difference, which is our spine, easy peasy. And we have a bunch of curves, right? The laser cut curves. What we want to do is we want to take all of these bad boys and we want to place them along the spine, right? That's where we're at right now. So to do so, I will, first of all, I will take the twinned curves. Let's focus on those. Bam. I'll take the twinned curves and I will shift the list of them. And I'll explain what is it that I'm doing once we have done it. So shift list, like that, with a factor of 1 and wrap turned on. So wrap is set to yes. So to just explain it in really simple terms, the original list of the curves is the outside one is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 right? When we shift the list, the first one is not the outer one, but one inside of it, right? So it's like 1, 2, 3, 4, 5, 6. And the first one, actually, since it's wrapped, it becomes the last one, right? So we basically just take a list of numbers and we just push it by 1, right? Or in this case, a list of curves. So what this enables us to do is then, if we just place them all into their separate branches, graphed tree, like that. This is required, by the way. And my voice. Graphed tree basically takes every element in the list and just places it into its separate little branch. And this is used to make sure that we will get pairs once we actually loft. So one second, I'm thinking of how to explain it to you. So what I want to do is I want to loft the first curve with the second curve. Then I want to loft the second curve with the third curve with the fourth curve, the fourth curve with the fifth curve, right? We want to get these ribbons in. And that's what we're doing, right? We're taking the first curve. So in this graphed tree, right? That's the first curve. And then when we shift it and graft it, the first curve is here. And we can just say loft surface. We need 2 curves, so I'll add port. We have curve 1, curve 2, and I just connect curve 1 and curve 2. And it just lofts like that. And notice how at first it went really nicely and then the whole thing just turned green. The reason why it's turning green is because it's also lofting between the last curve here, the smallest one, and the first curve here, right? Because it's wrapped, right? So it wraps back around. So what you want to do is you want to eliminate that. You want to remove it. And there's many ways of how you can do that. The easiest one is just to flatten tree. Bam. Or actually, yeah, let's do it what first comes to mind. That might not be the easiest one, but the one that comes to mind. So after we flatten tree, we just get a list of curves. Sorry, not curves. Now it's a list of surfaces back into one list, right? And then we will just reverse it. Because what we want to do is we want to remove the last one, right? So we reverse it. And we just simply cull, remove by index. Or will cull by index work? No, remove by index. And now since it's reversed, the index is always going to be 0. So I'm just going to type in 0 here. It doesn't need to be a range input though. Number constant, 0. Connect that. And that's it. Now we only have the ribbons here. So it's a little bit noisy now because we are looking at too many things all at once. So I'm just going to select everything except the last one. Right, like so. Right click, hide. There we go. Remove by index. Nice. All right. So moving on. Now what we want to do is we want to one second, just thinking real quick. We could reshuffle them so that it doesn't start from the largest one, like so, but rather it starts from the middle, because I'm just thinking of how it's going to be added in. Actually, let's do that a little bit later. We will turbocharge it a little bit later. For now, let's just take them and let's just move them, right? Move them onto the spine, finally. So to do so, I'm just going to use the move tool. Move. The list is the geometry that we move, like so. And the vector, basically how do we move it? Well, we need to figure that one out. I want to basically create a vector, and this is going to be a little bit noisy. Let me just hide the move for just a second. Hide the move node and zoom in here. What I want to do is I want to create a bunch of points going along here, cutting through the curves that we have made. And then from those points that we generate, I want to create a vector towards the points on the spline that we have generated with our evaluate curve. So that is going to be our movement vectors for every single one of these curves. I know it's hard to understand, or not understand, to visually, to see it without visually seeing it. So hopefully as I'm doing it, I'll slow down for this bit a bit because it's an important one. Hopefully you'll be able to follow. If you'll want me to explain something again, just let me know and I will do so. Okay, so the first thing is we need to go back, well, not back, but we need to create a line between our construct point right here. Let me zoom in. That's our largest curve, 0, 0, 0 point, and our first point of the smaller inner circle right here, right? We want to create a line between these 2 points. Line tool, like so. The first construct point connects to the line, and second construct point connects to the line, like so. So what you should see, apologies, come on, zoom to that. So what you should see is this line segment being created between the first point of the outer curve and the first point of the inner curve, right? I'll just drag it out over here so that it's we have some space here. Visual programming, the noodle fiesta is strong. Anyway, so with that done, then I want to intersect this line and all of the tweened curves, right? So I'm going to intersect 2 curves, probably, yeah, intersect 2 curves. So this line is going to be our curve 1, and all of the tweened curves are going to be curve 2, like that. And thus we generate a bunch of points, right? These points are going to be the ones that are going to be used to move the curves or the sections from where they are to where they should be, right? one thing before we move on, and it's an important thing, notice how for these sections, to remove the last one, we reversed the list. So they're now being counted backwards. Important. We need to do the same thing for these bad boys right here, the points, right? So I will reverse list. Bam. And now that's done. Now with that done, I can just simply, one second, I'm doing my best in terms of trying to fit everything in here. So with that being done, I can just simply create a vector between 2 points, right? For this move to actually work. So this move requires a vector by 2 points or between 2 points, right? That's the vector. Point 1 is going to be, you know, the starting point. So that's going to be these bad boys that we have created right now. We just connect that as our point 1, the reverse list output. That feels wrong. Wait. I feel like I should have probably... this probably shouldn't be grafted. But why is it grafted though? Yeah, it is grafted. So you can see from the dashed line that this is getting grafted. So what's happening is basically we're just multiplying it like crazy. It's amazing that it didn't crash though. Anyway, so before we actually plug it in, we want it to come in as one list because all of our slices are coming in as one list rather than multiple lists. So I'm just going to say flatten tree like that. Connect our reverse list to the flatten tree component, grab that, connect that to our point 1 component, and now this is all neat, nice, and dandy. Okay. So, once that is, or wait, Lernik is right. The reversing of the list, that part, yeah, I should flatten it here rather than, because the reverse then does nothing, because all of the graphs have only a single element in them. Apologies, a little bit of a hiccup. Let me just delete the flatten tree for now, just so that we're all on the same page. Delete the group here. Hello, delete the group. Oh, it's okay. Can we not have the whole damn group deleted? It's falling apart. Everything is falling. Okay, we're back. So after we intersected the two curves, the points got grafted, you can see here. So we want to push them back into a single list. So we use flatten tree, like that. After this, they're in the single list, which we reverse, like that. And then this reverse list is connected as our starting point for vector between 2 points. There we go. Okay. Whew. Then for point 2, all we need is our points on the NURBS spline, right? Our evaluate curve point output. And it's gonna be a long wire, so let me just drag over the move and vector between 2 points 2 here and just connect it like that as point 2. And you can see all of these are now placed neatly or correctly on the respected points, right? Along the evaluate curve. Okay, so that is, thank God. That works, that is done. Let's just give it a little bit more breathing room and let's move on. I'm just gonna check the chat if something's... Yes, I have noticed BeeGraphy has added in Control Z, undo. Thank God. I make mistakes, a lot of them. Control Z was very, very necessary. So now you can make mistakes as well. Okay, so with that being done, now what we want to do is we want to actually rotate all of these slices downwards, right? So that they go along the spline. And also I don't want to see the vectors, I'm just gonna hide them. So we want to rotate all of these slices downwards. And to do that, I'm just simply going to, sorry, something in my throat. To do that, I'm simply going to use the rotate tool. Geometry is going to be our slices. Angle is going to be 1.5707. That's 90 degrees. In normal human speech, that's 90 degrees. The center point is going to be the target points, like the evaluate curve points on which we moved them, because that's the point around which we want to rotate, like that. Is it rotating correctly? Yeah. And then the vector, that's important. The vector is going to be, if the spline is going towards the Y direction, the vector should be in X direction. So vector X, like that. Okay. And then I'll hide the move and we zoom into it and we get our little, maybe this is better. We get our little, shape now being tiled correctly on along the spline, right? So it's being placed there correctly. Okay, time to make it 3D. So you already know the drill. Extrude surface. Bam. Along the Y vector. Vector Y. Bam. What was the thickness that we used? Thickness, vector. There it is, 3 millimeters. Back in here, vector Y, factor 3. Connect that. And you can see we still have the same problem. Let me zoom in. We have the same problem. It's basically being extruded from the midpoint to the left, and now it needs to be moved back by half of the extrusion. So we just move. That does not move, not even close. Move. There we go. Along the vector Y by this divided by half, or divided by -2. Minus means it goes backwards and 2 is, makes it half. And then we don't need to look at the extrude surface anymore, and all of these now fit perfectly fine, into the shape. And this is because we're using low quality preset. I wonder if I just change this to high. Yeah, that works. Okay. So high quality preset looks like that. Hey, it's decent. Really nice. Okay, so that's basically the lamp, right? Or the rib cage for the lamp. Then once you glue everything, you just glue in the why am I struggling with that word? LED, the LED strip in here. You hang it. Not sure how, but you hang it. I guess wires. And you have a nice little parametric lamp in your living room. Let's make it a little bit more customizable, right? So first things first is, with this setup, it's always going to have the smallest slice in the front and the largest slice in the back. What if we say that the smallest slice or the largest slice is in the middle, and then it tapers down here and here, right? So basically we want the element number 1 to be in the middle, then element 2, 3, 4, 5, 6, 7, 8, 9, you know, kind of constantly switching sides, so that it tapers down. Should work, hopefully. We'll see if that works. And the way of how we can do that is just by simply reshuffling the data. You know, so we need to reshuffle these so that they are not counted. Let's zoom in. Boop. Let's zoom into them. We need to reshuffle these so that they are not counted 1, 2, 3, 4, 5, 6, 7, blah, or rather 1, 2, 3, 4, 5, 6, but rather they're counted. 1 second, I'm thinking. How should they be counted? Because you need to, yeah, you need to remove every second one. So the count should be, damn, this is harder than I thought, especially to explain. Where's my notepad? Or paint. Let's draw some stuff. So if we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? What we and this is hello, home. There we go. Brush. And this is the smallest one right now, and this is the largest one right now. What we want it to be is we want it to be 9 should be in the middle, right? Then 8, then 7, then 6, then 5, then 4, 3, 2, 1, 0. Okay, so the logic is we take this list and we eliminate, like for the first half of it, as it's increasing, for the first half of it, we eliminate 1, 3, 5, and 7, and so on. So every second number is being eliminated. Then for the second half of the list, in blue, here, we reverse it, right? So it needs to count downwards. It needs to count down, and we eliminate 8. 8 is eliminated. 6, 4, 2, and 0. And 1, 3, 5, 7, and 9 are kept. Okay. Yeah. So what we want to do is we want to split the list in half. We flip one of them backwards, and then we eliminate every other element in the list, and that should give us the correct sequence. A little bit of schizophrenia right there. Anyway, so with this remove by index, navigate to where you have your elements flat on the ground, right? Remove by index node. What we will do is we will, even and odds, right? Yeah. So what we will do is we will take nth. Come on. Take nth. We refresh. Give it a second to upload. Yeah, there we go. Okay, there's our nodes. Take nth. And I connect the removing this to, as my list, and it should remove every second, not every third, every second element, right? Like this. And it starts at 0. And then for this, I just simply, is this, and this is not like flattened or anything, right? It seems like it's a decent normal list. It's good. Okay, so that's done, and then I want to take nth again. Bam. But this time I also want to take every second one of it, but I want to start at index 1, not index 2. So basically we're getting the other row. These are the evens and these are the odds, I think. Should be. Anyway, then I will simply reverse the list, as we talked, in our paint schizophrenia portion of the course. Reverse list, like that. And we just simply merge it back into one list, right? Like that, list merge, click, add port. You can use shift key if you want, but I prefer to do it this way. It's cleaner. Always click, after you list merge, always click on the output to check if it's shit the bed or not. And it has, so the addresses are all fucky-wucky. So I don't know. Lernik, you're here in the chat. Explain to me like I'm 5. Why do we need extra numbers in both Grasshopper and, here? Why do we need extra zeros in the addresses so that, after we do like a simple operation, stuff does not match up anymore? Is there any benefit? Because in my whole experience of working with Grasshopper, I have not seen a single moment where this was beneficial. It just gets in the way. Oh, I see Grasshopper, but now it's BeeGraphy as well, right? So to fix that, I'll just flatten the list that is already flattened, but I will flatten it again. Flatten tree, because hey, more nodes, always nice. The more the merrier. Flatten tree. We like spaghetti. There we go. After flattening the tree, that gets rid of all of the noise information here, and then we get all of it in one list. So that's nice. And then we just simply, instead of using the original remove by index, we use the reshuffled values, or reshuffled sections, I guess, as our move target here, right? I'm just gonna hold the wire for a while so that you can see where it's being connected, right, to this move, like that. So the form becomes like this. That is what I want. But the problem now is that the vectors are all messy. And the vectors are messy because, well, we have reshuffled the sections, but we haven't reshuffled the vectors or the starting points for the movement, right? So what we want to do is we want to take this whole group that we have just created, take nth, take nth, reverse list, flatten, list merge, all of this. Right click, create group, like this. Take the whole damn group, Control C, Control V, copy paste. We follow the logic of the experts, Grasshopper and David routine in this case. Okay, Okay. No comment. Anyway, so we continue here. That is not the list that I want. We want the points, not the interpolate. So I will find, okay, it's now a little bit slow. There we go. So don't connect it to the interpolate just yet. Tween curves, shift list. Where is our line between 2 points? Vector by 2 points? What the? Huh? How does that work? So it's gone? Do I need to restart? Did I delete it accidentally? The whole line between 2 points thing and so on. Seems like okay. I will assume that this is me who did it, but now this is disconnected as well. Ooh. This is getting a little bit spicy. Let's slowly rebuild the whole thing. So one thing that we missed was, or not missed, but one thing that we lost was this 0.1 for vector between 2 points for movement. So I'm just going to rebuild it really quickly. You already know how to do it, so I won't explain it too much. So line between the 2 points, bam, bam. Intersect 2 curves. This is going to be curve 1. The tweened curves is going to be curve 2. So sorry, this needs to go here. There we go. So intersect between 2 curves. We get the points. We, I guess we flatten it. Flatten 3. And we reverse list. Bam. Okay, so we're back where we were, and now, just as we reshuffled the sections, I'm going to reshuffle the starting points to actually move the sections, right? Like that, and that. And the output of it, this final list merge, just connects to our 0.1 for vector between 2 points. And now the section should follow the curve quite nicely, almost. What the hell? Made a mistake or not? Maybe I did, maybe I didn't. Let's see. That gets reversed. Flattened. And the last one is fine. So after, so these guys are that's something wrong with these guys. Let's see. No, that's fine. Anyway, I'll need to look into it a little bit later. While I'll be looking into it, we can just chat a bit about it. So for now, that is where we're at. I don't like the floaty aspect of it. What if we do that? No. It's weird that it's doing it. I'm maybe missing something. But it doesn't seem like I am. Anyway, if someone can catch what kind of mistake I might have made, that would be appreciated. Thanks. If not, then it is what it is. Some bits are indeed floating. Maybe we can see it with the vector. The vectors are not being oh yeah, they're being shown from the 0, 0, 0 coordinates, so their anchoring points are not there, which is fine. That should be enough for us to see what's going on. Not sure if it's me or if it's BeeGraphy. The reason why I'm saying it is because when I was doing this, like the preparation for this was exactly how I set it up. And I might have made a mistake right now, but it doesn't feel like I made a mistake right now. So I will just ignore it, as we should. Okay, let's move on. Hide that. Okay, so now with this being done, it's only on one side, so either with odd or with even. What do you mean? It's only one side? Yeah. So it's only like here, like this area that it's messing up, but that makes zero sense, right? So it's only this portion. Because if I don't reset, don't reverse the list, will that work? I have an idea. Welcome to troubleshooting though, guys. Welcome to troubleshooting, yeah. There's a mismatch between the amount of sections that I have and the amount of vectors that I have. For some reason, if I look here, we have 19 sections, and if I look here, we have 20 vectors, right? So what we want to do is we want to get rid of the last vector, I think. Is it the last vector that we want to get rid of? I think it is. It's only 19 sections. Yes. Okay. So what we're going to do, okay, thank God, caught the mistake, and now the workshop can continue. Why did it work before when I was, anyway. So to fix it, what we will be doing is, wait, now it's all messy again. Give me a second. That's reversed, that's flattened, then it takes in, goes in here, gets moved. Oh, it needs to be reversed. Okay, that's good. So now what we want to do is we want to remove one of the elements from the vectors, right? So with all of the intersected points, and after we sorry, after we flatten them, I believe after we flatten them, we just want to remove nth, right? Remove nth from here, or not nth, sorry, remove by index. Like that. And the index needs to be 0. Let's see if that solves it. Yeah. That solves it. Okay. So that was the issue. We basically were removing, where was it? Remove by index. We were removing one of the last section from here, from these sections, but we were still using the original amount of points here. So now it's fine. And notice how the last two elements are being repeated. That is by design, and that is because here the list sequence count is set to 20. If you want it to not be repeated, you would need to just say, double click on the wire here, give it a second for the booleans to go through. There we go. And then you just want to subtract 1, -1 from here, connect that to count, and that is going to be all cleaned up, all nice, right? Apologies for a little bit of a hiccup right at the end, but hey, part of life. So that's the script, that's the definition, right? We are able then to export the CAD file for sections. We're able to manipulate the form of it, and we're able to see how it's going to look like. So let's play around with it, see where it breaks and what can be done. This is our final output, so I'm just going to, I'm going to select everything that we have, and I'm going to just hide everything. So you select everything, right click, and click on the hide button. Then I'm going to enable the preview of, that's weird, zoom to fit. I'm going to enable the preview of the last move node, and actually I'm going to give it like a material, apply material, or don't remember, apply material, right? Apply material, geometry. Is there like a texture node that I could use? No. Or is there? Okay, fine. I don't really care about the textures as much. Just add the color, switch the color to something, yeah, that's good enough, grayish, and then everything else is whatever, right? So we get ourselves the shape here, and then for the spine, spine. Let me just restart that. Okay. So after surface difference here, we have our spine that I can also apply material to. Someone is John Smith. Well, that's a very generic name, is saying that this is very difficult and that he hopes that there's going to be a reply for it. Why does the view just keep dropping out? Zoom to fit. There will be a replay. That's going to be available to see. And oh, this is weird. Restart again. The viewport is just glitching out. So and it's going to be on BeeGraphy's YouTube channel, right? So I will give them the recording, then they will upload it as a video. Okay, so the material has been applied. And now for the sections that are just simply tween curves, enable that, and those are we just keep them as they are. So now what do you want to be able to export? Well, you want to be able to export the geometries as OBJ files, OBJ exporter. So that one, as well as drag, holding down the shift key, this one. That's your OBJ exporter. And the twin curves should be possible to export as DXF. right? The drawing. And now basically your script, you're able to, you know, export it and import it into any kind of laser cutter and cut it out. Let's play around with the points, see how we can break this. It's gonna be easy to break this, but let's play. Let's see. So for the big one, I will keep the big one as it is. That's fine. But for the smaller ones, I will mess around with the what's the word? Sure. I will mess around with the control points, right? To see where does the tween break. So point number 1 is here. Actually, let me change that into that. Point, zoom out. There we go. Something like this. So point number 1 is in the top. Point number 2 is to the right. Point number 3 is in the bottom. Point number 4 is to the left. So point number 1, I can just I made it so that I can only adjust the Y value, and I will, the closer the Y value gets to 0, the more condensed the slices will be in here. The further it is away from 0, the more, you know, messy things will get. And for example, by just simply changing it like so, the tween didn't break. So let's take a look at how, you know, a 3D model looks. And that's this is what you're getting, right? Keep in mind that when you're doing self-intersecting objects like this, you cannot cut it from a single sheet of material anymore, because all of this is going to be, you know, drop out as a bunch of separate small rectangular pieces. But just to experiment, you know, with the forms and then seeing, you know, how do they behave, that's pretty neat. So that didn't break, which I'm quite surprised by, because it used to break quite a bit. Anyway, I'm going to drop it back to -50. Leave it in here. Then for the right hand side point, I'll just go for let's go for something smaller, like 25. There we go. And then for the last point, which is right hand side, -25 in this direction, right? So it becomes this very tubular thing, right? And then for the big boy, we can say that the right hand side should actually come in at a -100, like so, right? So we're basically adjusting the proportions as, you know, as we go, as what we want to do. That's basically where we're at. Oh, okay. So there was an update that fixed it. Okay, that's very nice. Yeah, the BeeGraphy is updating their stuff like crazy. The stability issues are usually gone. The new stability issues are introduced. But I like to see when things are moving forward. It seems like Rhino and Grasshopper development and so on is super stagnated, and right now like Grasshopper is in its own kind of CAD monopoly of kind of parametric CAD design, and they stopped innovating and they stopped, you know, developing at a fast pace anymore. I mean, the Grasshopper 2 has been in development for what, like 7 years, something like that, and it's going to be in development for 7 years more. It's just a lot of people that I talk to are getting tired of that kind of a mindset or that kind of a position where, you know, it gets there once it gets there. And it's nice to see, you know, like these new companies coming in and innovating fast. Of course, I also keep an eye out on what's happening in China. And there's a lot of companies that are kind of currently being constructed that will kick Rhino's ass. a few more years. In a few more years, unless there's like regulations and restrictions that might also happen. Anyway, so that's the lamp, you know, that's the parametric lamp. Quite a simple tool. Oh, let's make it a little bit more interesting. Like instead of 20, let's do 40 slices. Why not? You know, a little bit more pizzazz. A simple parametric tool that can get you quite interesting results. There we go. Took a while to calculate, but now we're here. Slap in some LED lights in there and you'll be golden. Share some news about the Chinese folks. It's really interesting to hear. NDAs cannot. It's basically right now there's a lot of tension between different countries in terms of the digital environment, right? And what kind of software is used on what kind of machines. That comes with the impending ban of TikTok in US and the whole geopolitical situation. So there's not just China, there's a lot of countries that are developing their own alternatives for Revit, Rhino, for everything. And, you know, certain countries have more resources that can be allocated to it, especially once the government gets involved. Let's say it like that, right? Which might be a flop, who knows? But when you have like a country with a lot of people and all of them, you know, start using a certain software, then that will definitely change the environment. I'm not sure how fast it's going to happen though. We'll see. Anyway, don't want to talk about it too much before any official statements or official releases come out, but things are indeed in the works. And no, I am not getting sponsored by those companies or those software packages. I wish, but anyway. Okay, so that is basically the workshop in its essence, right? That's how you can create the way of how I was thinking throughout this workshop when I was constructing this workshop is what's the use case for parametrics, you know, this kind of a how can you create an object and rather why should you create an object that is parametric rather than an object just, you know, 3D modeling? Because back in here, this lamp in particular, I can model out in what, like 3 minutes, something like that. Yeah, around 3 minutes, right? And then if I need to make another lamp, you know, with a little bit different of a form, that's another 3 minutes. So if I need to model out 10 lamps for 10 different clients, you know, that's on average like what, a few months of the turnaround in a small-sized company. So 10 clients, 30 minutes, right, to just model it. But there is definitely a benefit to just having a system set up that, you know, that is always going to make use of a laser cutter's bed size. And all you need to do is just adjust a few variables and then just press print, right, or press cut, and then get the output, right, from the laser. So thinking, like it forces you to think backwards, I guess, a little bit. It forces you to think about the design from the manufacturing standpoint. And I already touched upon the issues of that. When you think about the design from the manufacturing standpoint, then you over rationalize and you over optimize, and you end up with those Soviet building blocks. We used to call them Khrushchevka. Anyway, so the Soviet building blocks, the gray box blocked houses, that are highly optimized for construction speed and material, like everything, but they're just depressing, right? There's zero creativity. They're great from an engineering standpoint and everything else, but engineering in terms of the cynical, the mechanical engineering, right? Not the heat insulation and whatnot. Anyway, so when you force yourself to think only through the methods of making, you lose certain level of artistic quality, right? So in this workshop, I wanted to show that you can start with a certain restriction, a manufacturing restriction. You decide that it's going to be a laser cut, right? So it needs to be something that is going to be laid out on a sheet, and you don't want to use too many sheets. So the starting position is, how do we make use of the surface, a certain size of a surface, as much as we can, right? So in this case, it's 400 by 400 millimeter wooden, plywood sheet, and we're using the most of it as we can, right? And then from there on out, once you kind of made those restrictions for yourself, you try to reintroduce artistry and creativeness as much as possible, right? So you start playing around. Okay, what's the shape that I can draw inside of the sheet? How do I control the shape as well as possible? What if I have two shapes rather than an offset of a shape? Maybe that will give me more freedom. And you creating yourself the tool to not get bogged down by the rationalization of things, right? And then, it's always this struggle back and forth of, I want to make it rational, I want to make it cheap, but also I want to make it effective, and I want to make it aesthetic and inspiring for other people. I'm talking about design in this case. And you just simply need to always go back and forth, trying to figure out what's the best balance for it. Because, it's a struggle. It's always a struggle. And I think when it comes down to people using these parametric tools, there's not a lot who want the struggle, of having it optimized, of kind of preparing the mindset from the get-go of, manufacturing or simulation based, and then from there on out we move forward. Rather, people just tend to make things the analog way, or prefer to make things the analog way, and then you need to show the value of making it, the parametric way, which we're trying to do. I still enjoy parametricism, or ew, the dirty word. Just it has become like NFTs, hasn't it? Parametrics. It has been a downhill ever since Zaha died. Anyway, what are your thoughts on it? I want to hear from the chat. Is it going down? Is it going to come back? Is it at its peak? Is it stagnating? are there going to be more things just aesthetically, visually, things that inspire, artistic things that come from the field of computational design and parametricism that we haven't seen before? Or have we reached the bottom of the barrel with it? Because while you're thinking about it, that Voronoi bench, or Hadid bendy curves, it's getting to the point of same old, isn't it? Of course, I mean, the moment when the curves actually have a deeper meaning, not beyond just being the curves, structural and so on, that gives it a completely different level of quality that you should appreciate, that we should appreciate. But I'm talking in general, the visuals that we see on the internet that revolve around computational design or parametrics. I think we should not talk about it anymore. I think it should just be yet another tool that is placed somewhere in the back drawer and only used when it's needed. And a designer who works with parametric design should not be like a parametrics designer. It should be just a designer that sometimes, when it's needed, just whips out, some Grasshopper or BeeGraphy script, does a thing, and then continues on, thinking about the design. I'm not sure. Now I'm just blabbing. I think it will develop further, but it will go through some optimization. I hope so. I hope that it's going to be completely swallowed by the industry, and that every single software package will have a certain level of this kind of parametric optimization. Not optimization, sorry, integration. Parametric integration. I really hope so. Using restrictions like how do I use the most of my material is great. Starting with the idea how to make something new, innovative, cool doesn't feel like a way forward. I agree. Okay, Lars, yeah, that is true. Like just trying to create designs for the wow factor or for the factor of, visual inspiration for the community or whatever is definitely not the way to go. Like material usage and so on, like those are a little bit more important aspects than the wow factor. But, and it's a huge but, when it's only that, then we are left with the neighborhoods in which I grew up. As I mentioned before, the post-Soviet Union, building block neighborhoods that are that were cheap to build, fast to build, required low material, the housing costs were low, and so on. But at the same time, like the environment was really very bad. So I think if it's just that, then it's a problem. It needs to be going back and forth. I think it has a long way. It's bottleneck. The production techniques. Yeah, that's another thing. The production techniques. Laser cutting, 3D printing, CNC milling, weaving, knitting. What else? That's about it, right? Wire cutting. robotic manufacturing. So there are like these production methods, but the moment when you need to produce drawings for handmade stuff, you know, like when your parametric design needs to be handmade and you need to produce drawings, then immediately you're left with, you know, 200,000 drawings and a quote that is through the roof in terms of price, and suddenly parametrics becomes, you know, way too expensive. Right now, you know, I was looking at 3D printing. Wait, I'll show you. For example, this jewelry, right? This jewelry piece. Come on, focus. This is iron, like print 3D printed in iron, and this is cellular automata, right? Automaton. The cost of this is so high that it's impossible. Like, there's no way to make this into a possible even a jewelry piece. For a jewelry piece, it's too high, and it's made out of just iron, right? If this was silver, this would be insane. Well, okay, silver is a bad example, but like copper or something like that, this would be like, the price of this would be insane. So, and this is like a good example, I think, of parametric design that is, I mean, visually it's quite interesting, right? Like in terms of the form, but the price to actually make it, because what's the other technique of how you can make this? That there's nothing, right? So the price is way too high. And the moment the price drops down and we're able to print these out of metals for, I would say, if this was like 50 euros or 40 euros per print, this would be viable. This would be possible. Right now it's closer to 100, right? Then we can talk, but for now, the design is way too expensive, right? The realization of the design is way too expensive. But there is, while we're on the subject, there is a light at the end of the tunnel. This is, I'm working on the future video right now, but this is like a quick showcase, I guess. Remember this bad boy? Let me zoom into it. This is 3D printed, and it's 3D printed in one go. Like what's the word? Resin colored resin 3D print. I'm trying to get it as close as possible to the camera so that you can see the details. All right. This is a new technology of 3D printing that enables you to do full color RGB resin, extremely high accuracy, pretty strong 3D printing. So the technology is going, right? And once this becomes the norm, then everything beyond it will become a little bit cheaper, right? And so on, right? So eventually, I think the manufacturing techniques for these highly customized elements will become cheaper. Right now, not so much. One person was confused and thought I was using Blender. Nope, I wasn't. Will the live be available for viewing later? Yes, absolutely. It's going to be available on BeeGraphy's YouTube channel. I will send them this recording and they will be able to upload it on their channel. Oh, another long-term viewer, Mirzad. Hi. Welcome to the stream. You have missed it, but you already heard it. It's going to be available on BeeGraphy's YouTube channel. You could definitely do more or less the same lamp design that you just showed us, but using twice as much material because the parts can't be nested. Yeah, not even twice. If the parts can't be nested, then it's tenfold, right? It just imagine, go back here. Imagine, every single part does not fit in the previous one. Then maybe you can fit like 3 parts per sheet. But yeah, then there's 10 sheets would be needed. Yeah. So the start of it, at the start of the design, you do need to put yourself the aim of the design of what kind of restriction do you want to pose. But then the moment you fulfill that promise, immediately you start looking at the quality, right, of the form, of the space, whatever is it that you're creating, or the ergonomics, I guess, if you're doing product design. That's my point. Oh, Moreira, that's a familiar last name. Anyway, do you think that the depressing factor of these old Soviet housing blocks is in their simple and strict structure, or more to do with the lack of decoration and materials? I think it's the repetitiveness of it as well as the color of it. Simple as that. The repetitiveness of it really messes with the pattern recognition that we as humans have. It's very easy for us to recognize grids, like, something that is repeating, and we constantly are searching for patterns. That's what our brains are really good at. And when you're in one of those building blocks that is the same over and over and over again, you constantly, your brain is placed into this grid of elements, and you're constantly being stimulated. That part of the brain is constantly being stimulated. When you're in nature or in something that is more organic, more complex, more unpredictable, where the grid breaks, where the repetition breaks, the pattern recognition centers in the brain, they're a little bit more overwhelmed, and they give up, right? So it's not being triggered as much, so you get a little bit more relaxed. That's why we go to nature, is because nature in general is fractal-esque by its essence, like it's like a fractal, meaning that the complexity is so large that the pattern recognition, of the brain goes a little bit lower. And if it's lower by the means of giving up, not even trying to recognize patterns, and then we feel relaxed, we kind of chill out in nature, and then we go back into the city and we get stressed again because we walk in straight lines and we see straight lines and we see repeating stuff and grids. I could go on and on about this, but that's a big part of it, the a hyper repetition of the same element in a very predictable way. And I'll add to that, this is going to be a short one, but I'll add to that, my favorite building is the Nakagan Capsule Tower. Who would have thought? I never mention it. Anyway, and it's a metabolist building, right? Which basically repeats the same capsule over and over and over again. So how can that be my favorite building? And I still, shit on the Soviet building blocks. And the reason for that is the quality of repetition that those capsules, how those capsules are arranged, the quality at which they are arranged, the whole arrangement and the way the capsule towers work and how they work in tandem to one another and in tandem to the outside makes it so, or outside, I mean the surrounding environment, makes it so that the the overall arrangement of them is visually complex enough so that we don't see it as a repeating pattern, but rather we see it as a aggregate of things, like a hive of these boxes with a little circle in them, which I find to be quite beautiful. And if you look just how the Nakagan capsules are arranged along the perimeter of the core structure, it actually is quite a beautiful thing. I will be doing live streams of me modeling the Nakagan capsule towers, not just the capsule is done, but the towers themselves. So I'll talk much more. I'll talk much more about it. My cat is going crazy. Relax. Anyway. Yeah, the prices are indeed. The more 3D printers and CNC milling machines there are, the prices are going indeed go down. I feel like we definitely reached a point where the aesthetic has long lost its novelty, and also for the non-architecturally interested public. Yes, but this somehow distills parametric design down to its theoretical core, and those concepts are powerful and here to stay. Yes, so the concepts of parametric design and computational, they are getting baked into architecture, because now we are not just the people who are using parametric design tools, but also generally designers. They are thinking much more through parameters. What are the parameters that I want to follow with my design, from the get-go? And for which parameters do I optimize, which parameters do I control, and which parameters do I want to keep dynamic in my design? And if there is enough dynamic parameters, then they should choose parametric design tools. If there is not a lot of dynamic parameters, they're at least still thinking about the design in a parametric way, which is very valuable, very, very good, because that's one way of how to compartmentalize a complex topic or a complex task to do. I always try to follow your live or watch them later and learn a lot. Thanks for the amazing contents. Yeah, my pleasure. My pleasure. Oh, hi. Jason. Hi. Another long-time viewer. Are you going to publish the lamp you created to the market? Can I ask you to remind everyone about the computational design competition oh yeah. So the lamp that I have made, I will be publishing it into the market, but I will be doing so a little bit later on. Right now, I think it's a little bit more valuable to just, talk with the community and see where we are at with this whole computational design thing, and feel out the pulse of the community of what's the discourse that we can have around it. So instead of me going through the motions of changing the names of the sliders, I'm instead talking. But later down the line I will be publishing it, and you can just add the link to the published piece in your video description. Yeah, so, and the second one was the competition, the BeeGraphy competition. I might even have a slide of it. Give me a second. BeeGraphy, hello? Or not? I promised, and now, oh. I do. There we go. So, BeeGraphy Design Awards, they are doing a competition that is, the deadline for it is coming close now, but you can still make it if you join in. Since BeeGraphy is quite young, there's not going to be an insane amount of people that participate, so the chances of winning, if you are good in this parametric design, are pretty high. So I really suggest checking it out. I believe I have another slide with the prizes. There are multiple categories for the competition, and one of them, I believe, is lamp design. Don't copy this design. Don't attend the competition with the design that I just showed you. But basically, these are the monies that you can win, and the monies are nice to have, but also in generally just getting into the community of parametrics and so on, and just but like battling out your peers in this competition. It's just fun. So I really suggest looking into it. I'm in the way. There we go. So multiple categories. Just go to BeeGraphy.com. I am sure that they have all of the information already there, available for you. See what you can, where you would like to participate, and perhaps win some monies. So that's the ad. That's the ad for the competition as well. Right. Okay, so for now, I'm just thinking if there's anything else that I would like to address in terms of this whole parametric design. I guess final thoughts, final statements. BeeGraphy as a tool, as a platform, from my perspective, is extremely valuable. I really wish, and it's really hard to now talk about it when I see freaking Learning just spamming the chat. Learning is one of the founders of BeeGraphy, just writing in the chat, so I know that he's listening to every word, but I'm trying to be not to be biased. I really wish that BeeGraphy disconnected a little bit from Grasshopper in terms of what they're trying to do, and tried to find other ways of how they can create value within the tool, because they have managed to create value within the platform by the people being able to sell their designs. If that is going to work out or not, I don't know. It's really hard to get public interested in it. It's very easy to get enthusiasts interested in a platform where you can, customize your stuff and you can sell it, and there's a little bit of filtering going on from the administration, but not so much, and so on. Enthusiasts, very easy to rope in. The public, where's the carrot? Where's the candy that's dangling? So that part I like, and I think it's maybe just a marketing issue. There needs to be a lot of effort put into marketing it to the public as something that can be used, because right now it's hard to even find it. And then the main thing from me, just thinking about this platform, is the tool itself, and what kind of different value can it give compared to other tools. Why should I use it instead of just using Grasshopper, or instead of using anything else? What's the unique part about it? Is it that I can sell my parametric designs? That's not enough. That's not even close to being enough, right? Because the moment I don't sell my design in the first 2 months, I am quitting, right? And I'm just moving on to other tools, and then I'm selling my designs on Etsy, right? So there needs to be specific tools that Grasshopper does not have, that are possible to do in a platform that is cloud-based. Well, semi-cloud-based, is stored in the cloud. It's the computation is not in the cloud. So we'll see how it works out. I see the integration into e-commerce. Yeah, sure, maybe. But then the tool itself needs to be much more powerful, which I guess, you know, that's reasonable. It's still in the beta stage and it's still very young, so of course it's going to become more powerful. But I don't know. I think it needs to do more, or not more. Different things. It shouldn't just put its eggs in one basket. If it's doing that, then the chance of failure is very, very high, right? If it's doing like five different things. So for example, a tool that is used as an educational tool, like so BeeGraphy reaching out to different schools and trying to implement their platform into, let's say, architectural design or industrial design at bachelor's second year of education, you know, like creating these small courses for the universities and design schools that teaches parametric thinking, right? So that kind of stuff is what I'm talking about. But I'm not going to start brainstorming today. It's yeah, my cat wants to eat. Anyway. Okay. Sorry. So I have to leave. The cat is complaining. Thanks everyone for watching. I'll see you in the next one. Okay. Bye.